Bismillahirrahmanirrahim. Welcome students. Today we will do article 2.5 graphical analysis of motion. In today's lecture we will determine and interpret the slope of distance time graph, and from the shape of the graph we will determine the state of the body. That is, the body is at rest, or is it moving with constant speed, or is it moving with variable speed. So, a good way to show a relationship between two variables is to use a graph. A graph makes it easy to see if changes in one variable cause changes in the other variable. So, what are variables? The quantities between which a graph is plotted are called variables. One is dependent variable and the other is independent variable. In distance time graph, we have two variables, distance and time. Time is an independent variable. Independent variable, why? Because time does not wait for anyone or anything. It just keeps moving on. For example, if you want to go to a friend's birthday party and she lives quite far away, and with all the preparations you were doing for her birthday, her gift, then choosing out the dress for yourself, you just actually lost the track of time and now you are late. So you have to cover the larger distance in shorter amount of time. Obviously time is not going to wait for you so that you reach over there and then then it starts ticking again. You'll be constantly looking at your watch. So that's why you are dependent on time. The distance that you're going to cover is actually dependent on time. You will have to cover a larger amount of distance in a probably shorter amount of time. So time, being an independent variable, will be plotted on x-axis, as independent variables are always plotted on x-axis, and distance, being a dependent variable, it depends on time, it will be plotted along y-axis. And the distance time graph, it is going to tell us about the speed of an object over a period of time. So these are the types of graph that you will see, or you are going to interpret them. So we will be discussing these graphs with values right now, just to give you an in just to give you an information of what to assess, of what to interpret when you see these sort of lines in front of you. So if you ever get to see this sort of line in front of you, this red line which is horizontal to a time axis, it means that body is not changing distance, it is not moving, it is at rest, it is stationary. In the second graph over here, you see a steeper dashed line, and then there's another line. So the steeper dashed line indicates a larger distance moved in a given time, or in other words, the object has high speed. It has covered a greater distance in less time. Whereas the other line over here, this line, it represents that it's a speed, but it's a constant one, and it is increasing. It's increasing to the right, and the distance is definitely increasing constantly with time. So it is, in short, if we say, it is covering equal distance in equal time intervals. Yeah. Curved lines. The curved lines indicate that the speed is changing. Over here, in this first picture below, the object, it's speeding up, it's accelerating, it's getting faster, the speed is getting faster, and over here it's decelerating, it's slowing down. So the line on the graph that is curving upwards, this shows an increase in speed. It means that the object is moving, it's speeding up with time, and the line that is curving down shows that object is decelerating at a faster rate. It's slowing down. So why do I keep saying line and line again? Science students, it's very unfair for them to. It would be unfair that if the science students say a line, a dotted line, or a dashed line, why don't you say a gradient or a slope? So all these red lines are actually gradients or slope on the graph that represent the object's speed. This is the figure of a car traveling along a straight path in one direction and from point O, away from point O. And you can see that it has traveled a distance and it stops. So there's an observation table that you have made for the car. So let's suppose that the starting point was your home and car traveled a distance of 20 meters. For example, you went to a grocery store, you want to go to a grocery store, and after covering some distance, you parked the car in the parking lot of that grocery store. Obviously, you can't take your car with you to buy grocery. So, and then you're observing, you or some other person is observing that the car is in the parking lot for quite a amount of time. I don't see, well, there's not a quite amount of time. 25 seconds is not a big time when you're out for shopping or for grocery. So, so time as you're observing or the person is observing that after covering a distance of 20 meters, started ticking and you started observing actually. So 0 seconds, it was 20 meters, then again 5 seconds, again 20 meters. Then 20 meters was all, the distance was the same throughout, uh, changing time interval. You can see over here, you plot the graph, time along x-axis and distance along y-axis, and then you see 20 meters, since at 0 it was 20. Oh, I forgot to add 0 over here. So it's on 0 it's 20 meters, and then constantly on 5 it's 20, on 10 seconds again 20 meters, 15, because the car is stationary, it's at rest. So from this line, whenever you see a horizontal line which is parallel to x-axis, it means that the body is at rest, it's stationary, it's not moving. So when an object is moving with a constant speed, already know what a constant speed means, that an object is covering equal distance in equal intervals of time. So the gradient over here gives the speed of the object, and if you want to find the speed of the object at any point on this slope or gradient, it's going to be the same. Let's observe it individually. Let's suppose this car, it covered a distance, different distances, 0, 10, 20, 30, 40, and then you obviously noted down the time after every 5 seconds. So you see after every 5 seconds, after first 5 seconds, it covered a distance of 10 meters. Then you just take a pencil and a scale and you drop a line on the gradient, on the slope, and then perpendicular over here, you again drop a line on y-axis, and then you divide it distance by time. You will get the speed at this point and at this point. So it's going to be 10 by 5, 2 meters per second. Then again, 10 seconds, you will drop a line. Then over here, you will also observe the distance. So it's 20 by 10, it's going to be 2. And again, at this point, if you're going to observe the speed, it's going to be 30 divided by 15, 2 meters per second. So if, at every point on this gradient, when you observe the speed of the object, it's constant, it's 2 meters per second, which means that the object has been covering equal distance in equal time intervals. Now, let's suppose you want to find the time interval between any, you want to find the speed between any 2 points on a line, on a graph, on a slope. So it's pretty easy. You can take any 2 points, B and A. You can also put B over here. You can take A over here. It's up to you. You can use any 2 points. So the formula to find out the slope, the value of speed on the gradient, it's pretty easy. You have been doing in previous classes. Slope is equal to y2 minus y1 over x2 minus x1, and maths Probably you have been doing this. Or some students have been using the formula of slope is equal to rise by run. So what does rise mean? It is the vertical change between 2 points. The vertical change, vertical change along y-axis. So it is a vertical change between 2 points, or um, rise also means how many units you have moved up or down from point to point along y-axis. And what does run mean? It is the horizontal change between 2 points, horizontal, this direction, x-axis. Or it also means how far left or how far right you have moved from point to point along x-axis. So it's pretty easy. You can easily take the two values. For example, over here I've taken A and B, 2 points. I've selected 2 points on the gradient, and then this point is my y2. So obviously I'm going to take its corresponding values on x-axis and y-axis. I can take a pencil and a scale, and then I will draw up a line on y-axis, then here on x-axis, and I can find the corresponding value. Since this value is on y-axis, I'm going to take it as y2. This value is on x-axis, so I'm going to take it as x2. And then again at point A, I can draw perpendiculars on x and y axis, and then this my value is going to be y1, and this value is going to be x1. So I'm just going to put the values. Y2 minus y1, 30, minus 10, and then 15, minus 5. So my speed is going to be 2 meters per second. This is a checkpoint. Let's see. So you already know, graph is describing the speed of an object. This blue line over here, it tells us a steady speed. So if you want to find the speed over here, again, you can use the formula of gradient, of slope. Obviously gradient and slope mean the same thing. So when you take the values over here, y2, and then y1 and x1 are going to be 0 because the starting point is from the origin, it's 0. You don't need to write 0 and 0 again. If you want to, it's up to you. You don't get confused with it. Otherwise, you can directly take out the value. Speed is equal to distance by time. Maximum distance covered is 10, and its corresponding value along x-axis is 2. So 10 by 2 is 5 meters per second. That is the distance. That is the speed covered by the object. This red line over here, it can be divided into two portions. Firstly, you can see a little bit of interpretation that you can do is that initially the car is moving with a steady speed, with a constant speed over here till this point, till, when it covered 8 meters. And then after that, it went just, stationary. There was no movement. And then the graph is just like a straight line or horizontal line, which is parallel to the x-axis. So, this means that a body is at rest during this time interval. So let's calculate from this point to this point. If you want to find the speed between these points, again, it's going to be very simple. Since 0 is the origin over here, you don't need to write 0 and 0 again and again. Obviously 8 minus 0 is going to be 8, or whatever value it is going to be. But if you want to, if you don't get confused with it, you can use it. So speed is equal to distance by time. It's distance, maximum distance covered, 8, and then corresponding value on x-axis is going to be 4. So 8 by 4 is going to be 2 meters per second. That is going to be your speed during this part till 4 seconds. The speed is going to be like this. You can even check speed on various points. For example, if you want to check speed at this point, again, you can drop a line perpendicular over here and then a perpendicular line on y-axis, and then you can easily find out 4 and then divide it by 2. Again, it's going to be 2 meters per second. So you see at every point, if you want to find over here, so at every point you're going to, whenever you're going to calculate the speed, it's going to be 2 meters per second. It means that the body is moving with a constant speed. Over here, if you see, since there is no change continuously, you have a straight line. It means the body is at rest during 4 to 6, or probably if there would have been a 7 over here, so like 4 to 7 seconds, the body is not moving, it's stationary, it's at rest. So the speed is going to be obviously not changing. It's going to be like zero because the body is at rest. Over here, when an object is moving with a variable speed, as you already know, variable speed means non-uniform speed changing, continuously changing. There's a change in speed. And by definition, as you have learned in previous lectures, that when an object does not cover equal distance in equal time intervals. There are unequal distances in equal time intervals. Now let's see each and every point in detail. This is your time. You can see time 5, 10, 15. You have also plotted, oh, and you have also plotted distance 10, 20, 30. Now this is your gradient. This is your slope. This is a very non-uniform one. So I don't know why it keeps changing again and again. Okay, so if you plot the values, over here, uh, 5, and then you just want to find out speed at every point just to check that whether it's non-uniform or not. You take a pencil and a scale, and then you drop a line on the gradient at this point, and then again you're going to drop a line from this point on from this point with a pencil and a scale on y-axis, and then you divide it. So distance by time is going to be, let's suppose the value of distance over here is like 8 8 meters, so you can easily find the speed. 8 divided by 5. Then again over here at 10 seconds you want to see whether what is the distance, and you take a pencil and a scale and you drop a line on the gradient, and then over here again you drop a perpendicular on y-axis corresponding value to check. Obviously you're drawing it because you want to check a corresponding value on y-axis, and let's suppose the line, it ends up between 10 and 20. Let's suppose it's 20 meters. So and then again on 15 seconds you again check. You again take a pencil and a scale, you drop a line on the gradient, and then you check again the distance. Let's suppose it's 40 meters. So there is a huge difference. From 0 to 5 seconds you saw, yeah, obviously there was an assumption. You saw that it's 8 meters, then 10 seconds you saw it's 15 meters, let's suppose, and then in 15 seconds you saw it was 40 meters. So you can easily see that the body is not covering equal distances in equal time intervals. These are unequal distances and equal time intervals. So it means that it is moving with variable speed. Now, if you want to find the speed at any point on a slope or on a gradient, it's pretty easy. How will you find it out? You are just going to draw a tangent. So what is a tangent? As you have done in maths, tangent is a straight line that just touches the curve at a point. It is just a straight line that touches a curve. There are too many points that the line is touching right now. There is a possibility that there's many infinite points very close together. But over here, while I was drawing it, I was trying to, like trying to thin the line a bit, but I couldn't. Anyway, so let's suppose your tangent line is just touching point P on the slope or on the gradient. So for this point P, you have to find the speed. It's very simple. You just, at point P, you take a pencil and a scale, and then you drop a perpendicular on x-axis, and then on y-axis, corresponding value on y-axis, and you just, this tangent, you're just going to like make a triangle, stretch it down to x-axis, then over here to the maximum value, over here, yeah, it's like over here, and you take it, this is a triangle, take the, you use the formula of slope. Slope is rise by run, so y2. Since r and s don't have any values over here, but since this line is parallel to this line, you can take into consideration these values, because this is a rectangle, and in rectangle, two opposite sides are parallel. So rs is parallel to this side. So the value of r, you can take it as 30. So it's going to be y2, and s, corresponding value for distance, is going to be 0. So 30 minus 0, y2 minus y1. And if you see x-axis, again, this is y2, Yeah, it's y2. So you have this is going to be x2. So this value is going to be 15, and then again it's qs. So x1 is going to be 5. So 15 minus 5 is going to be 10. So 30 by 10. This Q should have been written over here. I don't know how it went up. Probably by the settings it got changed. So 30 by 10 is going to be, or if you don't want to write 0, you can just simply like 30 and 10. You can take the values. And then your answer is going to be 3 meter per second. But yeah, you have to take the values. So 3 meter per second is going to be the speed of the body at this point p. Obviously, since this is a variable speed, so at every point on the gradient, the value of speed is going to be different. It's not going to be same, it's going to be same. So basically we are talking about the average speed. We are taking the average speed, we are calculating the average speed at this point. Let's consider an example. This graph is a distance time graph for a moving car. A little bit of interpretation. Looking at the graph is that you're having a constant speed, and then the body's like coming to rest after some time. After covering this distance, is going to come to rest. It's going to become stationary. So the things that you have to find out are the distance traveled by the car, speed during the first 5 seconds, average speed, and the last speed during the last 5 seconds. Very easy. First part, distance traveled by the car, the maximum distance that is just traveled. You have to just draw a line with a pencil and a scale on y-axis to see the distance, because distance is along y-axis. The maximum distance is covered as 40 meters. See B part over here, this line is corresponding to 40, so it's 40 meters. That's pretty easy. Now speed during the first 5 seconds. Yeah, so speed during the first 5 seconds, you can see the time over here is in even numbers, 0, 2, 4, 6, 8. So you don't have a 5, but you know 5 lies between 4 and 6. You just want to take a pencil and a scale, and you just drop a line on the gradient, and then a corresponding line again with a pencil and a scale on y-axis, so that you get the values of y and x on y and x, on y-axis and on x-axis. So this is going to be your 5 seconds, and the corresponding value over here, let's suppose it's going to be 35. You can easily calculate the distance since the origin over here starts from 0. You don't need to write 0 if you want to, that's okay. So slope value is going to be y2 minus y1 over x2 minus x1. Y2 is going to be 35, and y1 0, then again x2 5, x1 0. Solve it. 35 by 5, 7 meter per second. That's the speed during the first 5 seconds. This is the speed during the first 5 seconds. Now the average speed is basically the total distance traveled by total time. You don't get what is happening inside during the intervals, during the events. You just take the total maximum value. So the maximum value is 40. You can see over here 40, and then you take the corresponding value on x-axis. Over here it's going to be 10. So 40 divided by 10 is going to be 4 meter per second. That is the average speed of the car. And distance traveled during the last 5 seconds. Last 5 seconds means that 5, 6, 7, 8, 9, 10. So you have to see the values from 5 onwards, 5, 6, 7, 8, 9, 10. And then it's very simple again. For 5, you have already drawn a line, a perpendicular line on x-axis, and you have dropped a line on y-axis to know the value. So it's 35 over here, and it's 5 over here, and then the last 5 seconds it ends up at 10. You already know this is 10 and this is 40. Now you can apply the value, the formula for slope or the gradient, which is y2 minus y1 over x2 minus x1. So y2 is going to be 40, y1 is going to be 35, and x2 is going to be 10, and x1 is going to be 5. And you'll solve it. 5 by 5 is going to be 1 meter per second. So during the last 5 seconds, the speed, you can see it's decreasing from 7 meter per second. Over here it was 7, and then it's 1 meter per second, and slowly at the end probably it will be 0 like something, because the body is going to stop. It's going to get stationary. You did assess it from the straight line that is is going to achieve. This is another example of a athlete who is having a 5-hour journey. So his speed during the first 2 hours, you have to find it out in meter per second. What did the athlete do between 2 to 3 hours? And what was the average speed during the end of the journey? Let's do a little bit of uh, guesswork of what is happening, looking at the graph, what is happening. If you see there's a straight line, constant speed, then you see this line over here. It is horizontal to it's a horizontal line parallel to x-axis, so it means that the body over here was at rest, and then over here it is going back to its original position. See, this is the maximum distance traveled, 12 kilometers, and then zero, suppose it was the starting line, it was your home, and then the athlete or the body, it did a journey back to home. So this is what is happening in the graph. Over here it's speeding up, over here it's speeding down, and over here the body is at rest. This is a sort of uh, picture that you're getting. So you have to find the speed during the first 2 hours in 1 and 2. You see over here the scale is in kilometers, distance in kilometers, time in hours. So first 2 hours, 1 hour, 2 hour over here. So you will take a pencil and a scale, you'll drop a line at this point on the gradient, and then corresponding value you will check on y-axis by dropping a line with a pencil and a scale. And it's pretty easy. You can simply divide the values distance by time. 12 by 2. So 12 by 2 is going to be 6, and units are going to be kilometer per hour, because distance over here is given in kilometers and time in hours. So your answer is going to be 6 kilometer per hour. But the question says that you have to find it in meter per second. Have to do a little bit of conversion. Oh, I did it over here. So you have to do a little bit of conversion. Kilometer per hour. Since 1 kilometer is equals to 1,000 meters, and this is in numerator, so you will multiply 1,000 with 6, obviously keeping the value of 1,000 in numerator. And then 1 hour, 1 hour is equal to 3,600 seconds. How? 1 hour has 60 minutes and 1 minute has 60 seconds. You have to go from hours to seconds. So 60 multiplied by 60 is 3,600. 3,600 seconds. So this value is in denominator, so you obviously have to write 3,600 in the denominator. So 6 multiplied by 1,000 divided by 3,600. Same as you have to write the values in the same way that the units are written, kilometer and hour. Similarly, you will multiply 1,000 in the numerator, and since the r is in denominator, you will divide the value of 3,600 in denominator. So you get the answer of 1.6 meter per second. This is the speed during the first 2 hours. Then what is happening? The question was, I forgot the question. Okay, what did the athlete do between 2 and 3 hours after the start of the journey? After the start of the journey, after 2 hours, let's see, it's doing nothing. There is a straight line, which means athlete just stopped and he was stationary. He was probably getting a drink or something. Quite. It's summer, so he might be, getting exhausted by all this running. Okay. And then in part C, what was the average speed during the end of the journey? And the end of the journey, let's see. End of the journey. The end of the journey starts, if you see from the graph over here, it starts at this point. So this is this starting point of the end of the journey. So what are you going to do? You take a pencil and a scale, you drop a line from this point on x-axis, and then a corresponding line on y-axis. After the rest, the journey is starting from this point, and then it is going down. Yeah. So now the thing is, what are going to be your y2, y1, and x2, x1? Since you have to find the values, you have to find the speed. So over here, if you see, since the downward journey is starting, this is the other journey. So over here, if you take the values, it's going to be 12. Now this is going to be your y1. And this is going to be your initial displacement, or the initial distance, sorry, initial distance, first position, the starting position, because after rest, it again continued. So this is your initial distance now, and then you covered a distance, and then you came to this point. So you will look at the corresponding value. This is 0, so 0 kilometers. That is going to be your final. And it means that from after covering 12 kilometers, you again started a journey, and that journey was from 12 kilometers to 0 kilometers. You were heading back home. So 12 kilometers and 0 kilometers. So it's going to be y1, and this is going to be your y2. Now look at the corresponding values on x-axis. Now this is 12, and again if you see over here, I drop a line and you see this is the point. This is between 3 and 4. It means it's 3.5. So your time over here is going to be 3.5 hours. Now this was your y1. Obviously then this value is going to be your x1. X1 is 3.5 hours. And over here your journey ended, so 0 kilometers. Your time was then 5 hours. This is going to be your x2. So you are going to subtract the values y2 minus y1 over x2 minus x1. So y1 is going to be your sorry, x2 is going to be your 0, y1 is going to be your 12. So 0 minus 12 divided by 5 minus 3.5 is equal to minus 12, 1.5. And then 8 kilometers per hour. This is the speed, 8 kilometers per hour, that the athlete was moving with during the end of his journey. And the minus sign is just indicating the direction it's heading back home. This is the sort of graphs that we have been looking at. If you see, um, all the type of graphs we have been discussing. The green line shows a fast and steady speed of a moving object from point O. The O point is the starting point, origin, and the blue line shows a journey, uh, starting, then accelerating, then decelerating. No, sorry, it's accelerating. It's just accelerating. It's just getting faster. Sorry, the red line, however, shows a journey. Firstly, with a constant speed, then it stopped, and then it returned back to its starting position. I hope you got the lecture today. It was not that difficult if you actually revise it, if you go through it again. If you still have any queries, you can contact me on my WhatsApp number. Share it and go. See you in next lecture. Take care. Allah Hafiz.